here you know that a cube is nothing but a cube is represented as a into a into a. We all know this formula. And after that, a plus b whole cube is nothing but a cube and b cube. In middle there will be 3ab of a plus b, right? Actually this is called actual method. Here if we take 301, for example, 301 can be represented as 300 plus 1. Here what we are doing is we are taking a as 300 and b as 1, and after that we do a plus b whole cube. That means a plus b whole cube equal to a cube, that is 300 whole cube, plus 3 of a into b, that is nothing but 3 into 300 into 1, right? Here a plus b is nothing but 301 itself, and plus b cube is 1 cube. Here easily you can see that 2 zeros will become 2 into 3, 6 zeros, right? Whole 6 zeros, and 3 becomes 27. 3 cube is nothing but 27. This is the cube, and here it becomes 900 into 301 plus 1. Until here you know that. After that I am taking this as 27000000, right? After that I am taking this as, clearly it's 9, and 3 into and it's 0, 3 into 9, 27, and after that you get 2 zeros, right? Plus 1, and adding these things, leaving 2 zeros, and we have 4 numbers, and here 2 zeros and 4 numbers. I am placing it after that 2 7, right? 0 9, and here I am placing 1. So this is the answer. In this method you have less calci and you have less mistakes. Let's check another method. This method is called column method of finding cubes, and this method is only used for 2-digit numbers. Right? Let's check. For example, the digit number be 91. We're taking 91. Let's do the column method. We are writing the a plus b whole cube here as a cube plus b cube plus 3a square b plus 3b square a. Okay, I'm writing these things in this order: a cube and 3a square b and 3b square a, and I'm also writing b cube, right? Let's come to this thing. After this you can keep a as 9 and b as 1, right? Then you get 9 cube here, and you get 1 cube here, and you get 3 into 9 square, and you here get 3 into 1 square into 9, right? 9 square is 81, 81 3s, it becomes 8 3s 24, and this is 243, and 9 cube is, you all know that 81 into 9, it's nothing but 1 and 70, okay, 729. Okay, 7 to 9, here it is. After that it becomes 1, and here it becomes 3 into 9 is 27, and here it becomes 243, right? Yeah. Coming to the next step, it's more fascinating. Coming to next step, you keep 1 because it is 0. You are always taking the unit digit, and you add 0 here, and we get the answer as 27, and you taking the 2, you take the 2, right? After adding you will getting 27, but you keep the 7 here, but you take the 2 here, you add the 2 here. After that you get 5 and 24, you keep the 5 here, the unit digit, right? You're always considering the unit digit, and you are putting down, and the rest of the digits you are forwarding, right? You get 24 here, and adding these two you get like 3 1, right? 753. So the answer will be, and you carry down the whole number, whatever gets here, the last digit, a cube, whatever the addition you get, you forward it, and you get 753. And this is the number, actual number, that is 91 cube equal to 753,571. This is the answer, and this method we have followed is called column method. Yeah, repeat the thing again, and you can see a clarity of column method. Okay, next, coming to the next scene. Whenever you have been asked that any number that is divisible and giving some reminder, this kind of questions will be asked in number theory. And let us check for example, a number is tripled, and then it is cubed, then the resultant is a multiple of 27. Verify or proof. Both are the same questions, whatever it is. If you have been asked questions like this, you need to take first the sentence itself. A number is tripled and then cubed, right? A number is tripled. Let the number equal to n, right? Here number n belongs to natural numbers. I am writing it as n belongs to capital N. After that I am writing tripled number equal to 3 into n, right? 3 into n. Here after tripling the number becomes 3 into n. After that the result is multiple, okay, then it is cubed, then cubed, right, equal to 3n whole cube. Now it becomes 3 cube into n cube, since we know that ab whole power n equal to a power n into b power n. Okay, let's see this. 3 cube is nothing but 27 and n cube is n cube. We can say that if n belongs to capital N, n cube belongs to capital N. So this is nothing but, therefore 3n whole cube is equal to 27n cube. That means 3n whole cube is a multiple of 27. It's the case, and problems which are number theory problems like this can be solved in this way. Let us take another example. Here we are telling that the numbers are belonging to this series. Example 4, 7, 10 and 13 and so on. You can all see that here this series is represented as 3n plus 1, since if n is 1 we are getting 4, right? 3n plus 1 becomes 4. If n equal to 2 it becomes 7. If n equal to 3 it becomes, right, it becomes 10 and so on. So I insist, let's take its original form as a number. So y equal to 3n plus 1 is our original number, where n is an unknown number and n belongs to a natural number. Now let's check. The question here is, belonging to this series is cube and resultant number must give remainder 1 when it is divided by 3, right? Okay, let's continue this one. Let's do y cube. It becomes 3n plus 1 whole cube, right? After that we are doing 3n whole cube, that is nothing but a cube, plus 3 into a, that is 3n, into b, that is 1, and 3n plus 1, that is nothing but a plus b, plus b cube is 1 cube. After this you are getting 27 n cube plus 9n into 3n plus 1 plus 1. Here if you observe carefully, here it is 9, it is 27, so you can take 3 as common. So 3 into 9 becomes 27 and 3 into 3 becomes 9. So I am taking 3 as common, so it becomes 9. 9 becomes 3. So 3n plus 1 plus 1. Here you can take, like here what happened is a into b plus a into c equal to a of b plus c. This is what we did here in this step. If you observe that we are taking 3 as common, still 27 is 3 into 9n cube and 9n is 3n. So taking common we having that. Here the whole term is multiplied by 3 and we are getting a plus 1. That means when the whole thing y cube is divided by 3, when y cube is divided by 3, we get remainder 1. Therefore the resultant series of cubic series of given series will give remainder 1 when they are divided by 3. Here we got the proof, right? It's nothing but 3n plus 1 whole cube by 3 gives remainder 1, right? This is the thing you should need to follow. After that, there are some sums that will make you think. For example, this is the sum given to me. Then we should make it fraction first. That is 1331 by 100, next 00, next 00. It becomes 11 square by, this is 10 power 6. We can also write 11 cube, right? 11 cube by 10 power 6. We can also write 11 cube as 100 whole cube. 11 power 6 as 100 whole cube, right? This is 11 whole cube. Since they are having common, we can take them as common. Since a cube by b cube equal to a by b whole cube, right? This makes this possible. Thus, the given number is a cube of rational number, that is 11 by 100, and that means this is a cube of rational numbers, that is 11 by 100. After that, you are also face some of the problems that are with minus. For example, you may have minus something like 512. Here, what is 512? It is 4 cube. Example, not 4 cube, 8 cube, I think so. 8 cube becomes 64 into 8. 8 2s are 32, right? 8 6 are is, okay, 8 6 are, wait, I need to erase this, right? 8 6 are, it is 48, and 48 plus 3 is not but 5. So I can write this is as minus 8 cube. When something exists as minus a cube, you can write it as minus a cube. That means this is minus 8 whole cube. Here you can write it as minus 8 is rational number minus 8 is rational number which is cubed to get minus 512. Similarly, you can also write some of the irrational numbers. What are irrational numbers? If a number exists in cube roots or some cube root without simplification, it is called a irrational number. For example, cube root of 12. Here, cube root of 12 is an irrational number because 12 exists as 2 square into 3, which doesn't has a perfect cube root. Thus, for example, you have been asked whether 729 is a perfect cube or not. Just you should find its cube root, right? That means you should write this one as 9 into 9 into 9. Since we know that 81 into 9 is nothing but 729. Here we do 9 cube and we are getting a perfect number. But the same question is asked like 728. Here 728 becomes, here it becomes 91 into 91 into 8, right? Here it becomes 91 into 8. Cube root of 728 becomes cube root of 91 into 8, where 91 itself can't be a 91 itself becomes something like 37 into 3, right? 37 into 3, no, actually it is Okay. Uh, 91, right? 91 when divisible by 7, it becomes 7 ones are and 13, right? Yes. It becomes 7 into 13 into 2 cube. But here individually the numbers exist, but the cube root of this number only exists, right? You can write this number as 2 into cube root of 2 cube into cube root of these two numbers, right? That means 2 into cube root of 91. Here the multiplication of a rational number and irrational number. This is irrational number and this becomes rational number. So multiplication of a rational number and irrational number results as irrational. Thus cube root of 728 number becomes irrational. And there is a concept called 2 and 8 are interchangeable, 3 and 7 are interchangeable, because here when you square a number when you cube a number which is ending with a digit 2, it gives a resultant number whose unit digit is 8. For example, you take 12. So if you take an example 2 cube, it gives 8, right? If you take an example 8 cube, it gives 512. That means 2 cube is giving an unit place 8 and 8 cube is giving a unit place 2. That means here these two are interchangeable. Similarly 3 cube, it becomes 27, right? Similarly 7 cube, it becomes 343. Here if you place something units place 3 and cube it, you're getting a units place 7. Similarly, if you get a 7, its units place become 3. Except this, all other gives the same number. 1 and 1, 2 and 2, 3, 4, right? 4 and 4, 5 and 5. After that 6 and 6. After that 9 and 9. 9 to same, 0 and 0. 0 to give same numbers. This is the result. Okay, means for example if you take 81 into 81 into 81, here the resultant number, the units digit will be 1. That is the meaning. Okay, this is the rule. The rule insists 3 is interchanged with 7 and 7 is interchanged with 3 and 2 is interchanged with 8 and 8 is interchanged with 2, except that every number gives the same number, exactly same number when it is cubed. This is a rule. When an examiner asks you what is the unit digit of this number, is unit digit of this number. The unit digit of this number is answer is 2, right? The examiner asks what is the unit digit of this number. The unit digit is 1, since it is 1. If examiner asks what is the unit digit of this number, the unit digit is 7. Okay, you can also see that 7 plus 3 becomes 10 here and 2 plus 8 becomes 10 here, except these combinations, all combinations gives the same result. These are the concepts you need to know about cubes, which are mainly asked in competitive exams and other exams too, right? We discussed about cubes today and this is the concept. All the best.